Warning, this video contains professional material and may blow your mind. Your discretion is advised.
Can you hear me now? Good.
We think nothing of communication, whether it be with our friends, family, neighbors, or even the random guy at the grocery store. Communication is not something that usually inspires wonder. But imagine a world where we communicate as freely with extraterrestrial beings from galaxies far, far away as we do with our own fellow Earthlings. Some scientists believe that this imaginary place isn't quite so far-fetched. These experts say that aliens exist and are searching for us just as we search for them.
Throughout this video, we will allude to SETI, which is much easier to say than what it actually stands for.
The search for extraterrestrial intelligence! SETI.
What I find so intriguing about the human race is that for as long as we have looked to the night sky, we've allowed ourselves to conceive the notion that distant worlds may very well be inhabited by creatures unlike ourselves.
Although the thought of an infinite universe with infinite civilizations goes all the way back to the ancient Greeks, a credible way to look for the hypothetical life wasn't proposed until the late 1950s. The search for extraterrestrial intelligence began in 1959 when Cornell physicists Giuseppe Cacconi and Philip Morrison published an article in Nature. They proposed the idea of scanning the sky to listen for non-random patterns of electronic emissions to detect other life. Frank Drake, a young radio astronomer, had independently reached the same conclusion in 1960. At the National Radio Astronomy Observatory in Green Bank, West Virginia, Drake conducted the first microwave radio search for radio signals. Called Project Ozma, the NRAO radio telescope listened for radio signals for 6 hours a day for 4 months. Within a year, a meeting was hosted in Green Bank to explore SETI.
Contrary to popular belief, microwaves and boomboxes were not used to establish contact with extraterrestrial life.
As I planned the meeting, I realized a few days ahead of time we needed an agenda. And so I wrote down all the things you needed to know to predict how hard it's going to be to detect extraterrestrial life. And looking at them, it became pretty evident that if you multiplied all these together, you get a number, N, which is the number of detectable civilizations in our galaxy. This, of course, was aimed at the radio search and not the search for primordial or primitive life forms. And so, the birth of the Drake equation.
What's the Drake equation?
Really? Are you familiar with the Drake equation?
The one that estimates the odds of making contact with extraterrestrials by calculating the product of an increasingly restrictive series of fractional values, such as those stars with planets, and those planets likely to develop life. N equals R times FP times NE times FL times FI times FC times L.
Yeah, that one.
The first variable, R sub star, is the average rate of star formation per year in our galaxy. This variable is defined by considerable astronomical data and is the least disputed. Using the age of our Milky Way galaxy and comparing it to the oldest visible galaxy, we see that the average rate of star formation is around 8 stars per year.
F sub p is the fraction of those stars that have orbiting planets. When the Drake equation was created, it was believed that planets could only be found in single-star systems. This removed nearly 50% of the planets in our galaxy. It has now been shown theoretically that multiple star systems can in fact have orbiting planets. This enlarges our estimate from 50% to 5 to 90%.
N sub E is the average number of planets per solar system that
that has an environment suitable for life.
Fun, 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 fun.
While there's debate on how Earth-like a planet has to be to sustain life, we assume liquid water is essential.
Using our solar system as an example, we know this variable is at least 1, but possibly 2, 3, or even 4, depending on if life turns up on Mars or another planetary body, such as a moon of Jupiter. However, most scientists would estimate it between 0.5 and 2 or 3.
F sub L is the percent of planets that do go on to support life. Scientists are split on this question, but most tend to think that some life exists. This variable could be virtually any percentage.
Variable F sub I stands for the fraction of planets that can actually support intelligent life. This value is very controversial. Most people who support the low variable would claim that although Earth supports a numerous amount of species, only one has become intelligent. Some favor a much higher variable and argue that with the general increasing complexity of life, intelligence on another planet is inevitable.
F sub c is the fraction of these species that are willing and can communicate. As we reach further into these variables, the more guessing scientists find themselves doing. With no cold hard facts, we must define communication and move from there. This variable is probably the most wide open. It could be 0% or 100%.
Ah yes, my old friend L, the last variable. It's also the least known variable. It's the average lifetime of a communicating civilization. You see, we don't really know how long a communicating civilization normally lasts because the only example we have is our own. And we've only been communicating since the 1950s. And we don't really know when our civilization will end. It could end tomorrow, it could end in 1,000,000 years.
It is important to keep in mind that the Drake equation is just used to estimate the number of detectable extraterrestrial civilizations. It does not get us any closer to finding those civilizations, it merely predicts their existence. However, it provides hope for SETI and gives us a reason to continue searching. And action.
1, 2, 3.
And action.
Go! Throughout this video we will what? Loop. Okay, I forgot that word. You ready?
1, 2. Okay, to stop moving around. Hang on.
Way too quick. Nope.
We've only
Cut. Do not say cut.
Shut up!
Just put me.
Gotta read it a little bit. You hear me now? Good.